atom. This is something we now take as a given and one of the things you learn right back at the beginning of high school and secondary school chemistry classes. Despite this, our ideas about what an atom is are surprisingly recent, as little as 100 years ago. Scientists were still debating what an atom looked like. Let's take a look what the K-model proposed and how they changed over time. Let's start in the 1800s. The idea of atom was long before. In fact, we have to go all the way back to ancient Greece to find its genesis. The word atom actually comes from the ancient Greek and roughly translates as indivisible. The ancient Greek theory has been credited to several different scholars, but is most often attributed to Democritus and his mentor Eusebius. Further ideas about atoms were rudimentary compared to our concepts today. They outline the idea that everything is made up of atoms, invisible and indivisible spheres of matter of infinite type and number.
It was a long wait, however, before this foundation will be upon. It was still 1803 that the English humanist John Dalton started to develop a more scientific definition of the atom. He called the billiard model. He drew on the model ideas the ancient Greeks in describing atoms as small, hard spheres that are invisible and that atoms of a given elements are identical to each other. The latter point is one that pretty much still holds true, with the notable exception being isotopes of different elements, which differ in their number of neutrons.
However, the neutron will be discovered until 1932. We can probably forgive Dalton this oversight. He has also come up with theories about how atoms combine to make compounds and also come up with the concept of chemical symbol for the known elements.
First breakthrough came in the late 1800s with English physicist Joseph John Thomson. Discovered the atom was not indivisible as previously claimed.
In 1904, he put forward his model of the atom based on his findings dubbed the plum pudding model. It envisaged the atom as a sphere of positive charge with electrons dotted throughout like plums in a pudding.
Ernest Rutherford was a physicist from New Zealand who studied at Cambridge University under Thomson, the founder of nuclear model. He devised an experiment to prove atomic structure which involved firing positively charged alpha particles at a thin sheet of gold foil. Rutherford decided that the atoms were mostly empty space, but had a dense core known as the nucleus.
Niels Bohr was a Danish physicist who set about trying to solve the problems with Rutherford's model. He realized that classical physics could not properly explain what was going on the atomic level. Instead, he invoked quantum theory to try to explain the arrangement of electrons.
At any rate, the model is still required referring at this point. Many scientists were investigating and trying to develop the quantum of the model of the atom. Chief among these was Australian physicist Erwin Schrödinger, who you probably heard of before. In 1926, Schrödinger proposed that rather than the electrons moving in fixed orbits or shell, the electrons behave as waves. Schrödinger solved a series of mathematical equations to come up with a model for the distribution of electrons in an atom. His model shows the nucleus surrounding by clouds of electron density. These clouds are clouds probably truth. We don't exactly where in it electrons are regions of space are referred as electrons orbital. It's perhaps understandable why high school chemistry lessons that don't lead in straight with this model. Truth is the accepted model today because it takes a little more than time to get your head around.
Rangers was not quite the last word on atoms. In 1932, the English physicist James Chadwick, a student of Ernest Rutherford, discovered the existence of the neutron, completing our picture of the subatomic particles that make up an atom.
The story doesn't end there, either. Physicists have since discovered that the proton and neutrons that make up the nucleus themselves are both divisible into particles called quarks. But that's beyond the scope of this post. At any rate, the atom gives us a great example of how scientific models can change over time and shows how new evidence can lead to new models.